Hello dear learners, I'm Zinnah, your chemistry guide. In this video, I'm going to discuss on diamond and graphite. Diamond and graphite are allotropes of carbon, which means both of them are made of carbon atoms. Though they are made of carbon atoms, but they are hugely different in terms of their look, uses, and price. We're gonna see here what makes them so different, though they are made of same kind of atoms. Diamond with the code 44 and 4. Graphite with the code 3, 3 and 3. We're going to explain them here. Both diamond and graphite are made of carbon atoms. And carbon atom means having 4 electrons in the outermost shell. In diamond, a carbon atom makes 4 bonds with 4 adjacent carbon atoms. Here's a central atom, dot and cross diagram. And this happens for other carbon atoms too. This goes on. And in graphite, a carbon atom bonds with 3 carbon atoms, leaving 1 electron unbonded. Here, the same thing happens for these 3 carbon atoms and all other carbon atoms in graphite. And you may think that the shape of this structure would be like this, and shape of this structure should be like this, but they are not, because of equal repulsion between the electron pair and electrons pair here. Equal repulsion makes their shape. This is here tetrahedral for diamond, and this is trigonal planar for graphite. And here you see 4, 4, 4 means each of the carbon atoms makes 4 bonds with 4 different carbon atoms using all 4 valence electrons. And for graphite, each of the carbon atoms makes 3 bonds with 3 different carbon atoms using 3 electrons. 1 electron is here left behind. Now you just get these 2 structural units. And when there are many units, uncountable number of units held together, bonded together repeatedly, that makes here the structure of diamond. And for graphite, the same here, many structural units repeatedly join to make a layer molecule. The layer molecule itself is not graphite. This is graphene. And to be graphite, there should be many graphene. A single layer molecule is called graphene. So diamond as a whole is a single molecule with 3D structure with network covalent bonds. You see here, each of the carbon atoms makes 4 bonds with 4 adjacent carbon atoms, and that goes on. In graphite, here you get 2 types of bonds. This is in a layer. Look at the layer, you will get atoms are covalently bonded. And between the layers, the bond is weak. This is weak intermolecular forces. And this is together is graphite. Based on the bonding and structure, we are going to sum up the differences between diamond and graphite in a single table. Bonding. Each carbon atom is bonded with 4 adjacent carbon atoms using its all 4 valence electrons to form 4 strong covalent bonds throughout the molecule. And for graphite, each of the carbon atoms is bonded with 3 adjacent carbon atoms using 3 valence electrons to form 3 strong covalent bonds throughout a giant thin layer molecule known as graphene. And the layer molecules, which are graphenes, are held together by weak intermolecular forces or van der Waals forces of attraction. Dot and cross diagram, this is a single unit for diamond, and this is here a single unit for graphite. Structural unit for diamond, this is tetrahedral, and this is for graphite, it's a trigonal planar. Structure, the many tetrahedral units together, and here many layers together. See more differences. Molecules a piece of diamond is a single molecule, whereas graphite, every graphene or every layer is a molecule. And hardness, very hard for diamond, and graphite is soft and slippery. Electrical conductivity, diamond is non-conductor, whereas graphite is good conductor of electricity. And melting and boiling points, both have high melting and boiling points. Appearance, diamond looks very shiny and graphite is dull. Uses, jewelry and glass cutting, and that's for graphite. Pencil lead and lubricant. Now explain the following properties of diamond and graphite. The first, both diamond and graphite have high melting and boiling points. 2. Diamond is very hard, whereas graphite is soft and used as lubricant. Diamond is a non-conductor of electricity, but graphite is good conductor. And then next question, draw the structure of diamond and graphite. So start with the first one. Both diamond and graphite have high melting and boiling points. And for answering these questions, you first have to remember or recall the structure of diamond and graphite. If these two features in your mind, then you can easily answer the questions regarding diamond and graphite. See here, both are macromolecules. For melting and boiling them, is the first point. The key point is you will have to break their covalent bonds, because in diamond, there are only covalent bonds. It's giant structure. For graphite, though there are intermolecular forces between the layers, but separating the layers is not enough to melt or boil them. For melting or boiling, you need to break the covalent bonds, split the bonds. And as they are macromolecules, so a lot of strong covalent bonds are required to be broken. And this needs a very large amount of heat energy. Diamond is very hard, whereas graphite is soft and used as lubricant. See here, a piece of diamond is a single macromolecule with strong network covalent bonds, whereas graphite consists of layer molecules which are held together by weak intermolecular forces. And under stress, the layers can slide over one another. Is to a layer and they can slide. Diamond is non-conductor of electricity, but graphite is good conductor. And all the electrons in diamond are engaged in bonding. So there's no free electrons. See here, tartan cross diagram, the middle carbon, four electrons are engaged, and this fulfills outer shell. So electrons cannot move about. So there's no free electrons to every of the carbon atoms. An electron from every carbon atoms in graphite is unbonded. Here's the unbonded electrons and will be delocalized. And these delocalized electrons will be able to move freely throughout the lattice and conduct electricity. And for electrical conductivity, recall the structure. The atoms consist of electrons, and if the free electrons here from every of the carbon atoms move across the layer, there will be some resistance. So electrical conductivity across the layer is somewhat poor, but between the layer, along the layers, the electrical conductivity is much better because there is empty and there is no repulsion. And then draw the structure of diamond and graphite. For drawing this, you cannot draw the whole diamond or graphite structure. You need to just draw only 3 or 4 structure, the unit structure together. This is 1, 2 together, another is here. This is enough. And for graphite, you need to draw 2 layers at least. In every of the layers, there should be at least 3 hexagons. And this is a good diagram. Thank you. Thank you very much. I hope this video has made your concept about diamond and graphite very clear. To get more videos of this type, stay with us by subscribing this channel. You may share this channel with others. Thank you very much.